Okay, yeah, I think most of you are here. So before we start our class, I want to ask you about the final. So the way I think about it, the way it's going to be structured, it should not take more than 2 hours. But I will give you a 24-hour period to finish it. So you can just take any 2 hours out of that 24-hour period. And I want to ask you when would be a good period for you guys. So I know you have exams on Monday or Wednesday or something. So I'm thinking I could post the final on like 12 p.m. of on Thursday, 2 weeks from now. And then it will be due on 12 p.m. on Friday. Would that be a good time?
Yeah, that's fine. When you say post it, do we have a fixed time to take it, or do we just have to turn it in by then?
Um, so you can take any time within that 24 hours to finish it, but the way it's going to be structured, it should not take more than 2 hours for you. So don't worry if you cannot devote a lot of time during that 24-hour period. As long as you have 2 hours free, you're fine. Okay, so I'm not hearing any no's. So I guess that's a good time for everybody. Okay, so I'll do that then.
You said what day again?
So it's gonna be from noon of Thursday, March 11 to noon of Friday, March 12th.
Okay, thank you.
Okay. Yeah, basically the end of that week. Okay. So
Professor, really quickly, what's going to be the format of the final? Is there coding on it or multiple
yeah.
choice, short answer?
Well, I'll talk about that in the end after I finish the lecture.
Okay, that sounds good.
Okay. So today we're going to talk about data visualization. So this is also a topic that could take a whole course, but I'm just going to give you a very brief overview of what we usually do and why we're doing that and what are the good practices. So first, why are we doing data visualization? So if you look at these numbers, okay, and can you count how many times number 3 occurs among these numbers?
No.
Okay, so
5.
I bet you cannot do that within 5 seconds, right? However, if you look at this figure, how many 3 are there?
6.
6?
It's 7.
Okay, so you can clearly see that there are 7 3s, right? And now most people can do it within 2 or 3 seconds. So that's an example of how data visualization works. It just magnifies the pattern in your data so that it's easier for your reader to see or for yourself to see. So throughout this course, we've been talking mostly about statistics, and you can think of those as you have some data set and you're mapping those data set into some numerical summaries of your results, whether that's regression coefficients, whether that's some prediction for some y variable given x variable, and then you can interpret your result and get your conclusions. So those would be estimates, tests, confidence sets, and predictions. Okay, but you can think of data visualization is also a mapping, but it's mapping from data sets to some visual representations. So then it's also something that you should think about how to systematically think about those mappings and how to implement them and what are the good design practices. So just like any statistics, there is also some things that you should do or should not do, and ways that you could map different kind of data to different kind of visual presentations. And the goal of data visualization, there are mainly two goals. The first goal is to communicate. So you already have some results and you already did your analysis. And then when you present the results to other readers, you could use data visualization to do that. Usually statistics are kind of abstract, right? So when you give some additional figures, that would sometimes be more persuasive. And the other goal of data visualization is to analyze or explore. And that is to discover patterns in the data, not for the readers, but for yourself. So when you first get some data, you could do some exploratory analysis. And a lot of that would be different kind of visualizations about the data. For example, if you have X variable, Y variable, and then the first thing you want to do, if you want to see what's the relationship between those two variables, you could just do a scatter plot, right? That does not rely on any model. However, it will help you to see what is the pattern in the data. And that could also give some guidance for what you can do next. So if you see that it's a linear relationship, then you could just do a regression and have a very good fit. However, if it's a nonlinear relationship or something else, then you could use other models. So I want to first just talk about what are the good practices of data visualization, and then give you an overview of what kind of data visualizations there are. So the first thing about data visualization is that, well, this is regarding the communication part, okay, the first part. When you're using the figures to communicate some ideas, you should know your audience, what do they know and what they are interested in. And these data, these figures that you have should be fit to their needs. And there are usually two kinds of figures. One is exploratory, and that is neutral. So like the one on the left, I don't know if it's big enough. So this is the sales performance of some people, okay? So you can see the total sales, number of deals, and then this sales over time. And then you have the performance of the different salesperson. And then there's the revenue by quarter. Okay, so it's these are all facts, and they're presented in a very neutral manner. And then as a reader, you can read this figure and draw your own conclusions. And the second kind of figure is it has an opinion, so it's not entirely neutral, and it's to present your opinion and to persuade people. So this figure here, the message that it's trying to convey is that there's a lot of people that died in Iraq during those years, right? And you can see this very huge number that looks big, okay? However, you could also do it in a different way. And then that would totally change the message. So if you look at this figure, it's based on the same data. But then what this shows is actually the number is declined over time. Okay, so depending on how you present the figure, it could tell two sides of the same story. And whenever you do data visualization to communicate, the best thing you could do is to don't make your audience think, so that the visualization is just direct and effective. Okay, so let's look at some examples of how to make that effective and direct. So if you looking at this figure, okay, so this is a bar chart, right? You have two bars, one is A and one is B. And can you see how much longer B is relative to A?
Five times longer.
About 4 or 5 times. Okay, so actually it's 4 times, but you're pretty close. So in this figure, these are two linear straight lines. Okay, and one is A, one is B. A is steeper than B, right? But how much steeper is A?
3 times.
3 times. It's 4
Ugh.
times, but pretty close. Okay, so now how much bigger B is relative to A? So these are the two pies,
4
4
times.
times.
two circles, 4 times. I think that's pretty far away from the truth. B is actually 10 times bigger than A. But when you do like area, it's not easy to see, right? You would think that it's only 4 times. Okay, how much darker is B relative to A?
How would we know this?
You wouldn't know this. It's 2 times. Last one. A is this greenish color, B is this yellowish color, and most green would be 2. And then on the other hand, you have 16. How much is B?
Nine.
9. It's actually 4 times. Well, that's about 8. Okay. So you can already see that when you are doing this quantitative comparisons, there are some graphs that are much more efficient than the others. So the most efficient one is always the bar chart, which is the length. Okay, and similar to that, you can also use the position on the graph to show the magnitudes. And looking at slope would be a little bit harder, and area would be even harder, and then the intensity and color or shape is would be just almost impossible. So when you are doing this quantitative comparisons, you should always use a bar chart because the length of the bars is very easy for humans to see. However, if you are doing some ordered categories, you could use like colors or intensity. And then the good practices of data visualization can be just summarized by these few points. Okay, so first, you should always show the data directly. And second, related to that, is that you should reduce anything that's not relevant to what you want to say. Okay, so everything that doesn't help with the message you want to communicate, you should drop that from the graph, and you should reduce all the clutters. And the third rule is that you should always integrate the text and the graph whenever possible. So let's also look at some examples and see if you think they are good data visualizations or bad data visualizations. By the way, another point about to show the data is to not is to show the data in an unbiased way and not a misguiding way. So one thing about that is that when you are doing the axis, usually you should always start from 0. Otherwise, it's very hard to see the actual magnitudes. So sometimes you see these figures like there's a huge decline in something, but then when you look at the actual magnitudes, it's like 10.1 and 10.05. Okay, so that's actually not much of a change. But then if the axis is not accurate, so it could be misleading. Okay. Well, let's look at some examples. So this first figure, well, first problem is that you don't even know what these things are. Okay, so they should explain about that. And then this is showing these 4 things over time. Where do you think this can be improved?
You could add a legend.
Yes, you can have a legend to explain what these things are. What else?
You can expand the title instead of abbreviating it.
Right. Yeah, that's also about these titles. They're not clear. What else? So it depends on what your goal is with this figure, right? Is that, do you want to compare these 4 groups? Like they have different trends over time, or what is the message that you want to say in this figure? And the other thing you could, the other potential problem is that the only important thing in this figure, take this figure for example, the only important thing is this line, right? However, it's very hard to see that line because first you have these lines that are these grids, and second you have this x-axis that is actually even thicker than that line. So you should try to emphasize that more because that is your data. The other things are just supplementary. Okay, so the first issue is that the graph should emphasize the data. However, we are not seeing that data very clearly. So you should reduce those unnecessary clutters like the y-axis labels, percentage signs, and tick marks, and also add labels for these things. And then you could have this figure, which looks much better, right? So now you know what these 4 categories are. These are 4 different kinds of assistance cases, I think, for either disability insurance or some kind of social welfare program. And then you have these 4 groups: adult only, no cash, welfare cash assistance, and SSI cash assistance. And then it also emphasizes this line, which is the data. So now you can, if you want to see how these 4 trends compare, you can just look at this graph and see that pretty clearly. Okay. So second thing, this graph, it's the education and exports of office machines. On the x-axis, you have the years of schooling for all of these countries. And y-axis, you have the exports of office machines. And then all of these little dots are countries. And there's also a line that is the fitted regression line that shows there's a positive relationship. So what's wrong? What can be improved with this figure?
You don't need to label all the points.
You don't need to label all the points, right? Because it's very hard to see them anyway, like for this part.
You might want to have the line be a different color. It might be hard to see the line too.
Right. So if you want to emphasize that line, you could have it in different color or have it thicker. And if you want to point out some countries, you could still do that in this way, but you don't have to label all the countries. So that's pretty much all the problems. And also the all of these country codes, you don't know what they mean. So it may be obvious to some people, but not obvious to everyone. So you should spell out the full names of those countries if you want to highlight them. So this figure would look much cleaner. You have these dots that are now in a lighter color, but also keep this line in the middle, and it's very clear to see that the positive relationship and all of these dots are kind of around that line, and you can still emphasize some countries, right? And now it would be much easier to do that without all of these labels. Okay. Next one, we have this expected lifetime earnings of different groups. There's the first group that finished no school, second group that finished only 1 year of college, 3 years of college, finishes 4 years with 2.0 GPA, 3.0 GPA, and 3.75 GPA. And you can see that their earnings are sort of higher if they finish more education and if they have higher GPA. What can be improved with this figure?
Maybe you have too many groups. Maybe you want to have 1 to 3 years be a category.
Okay.
Or
Okay.
The figure starts at like 400, which could be misleading.
Right, it starts from 400, and if you don't look carefully, you might conclude, or you might draw some wrong conclusions, right? If you only look at these bars, then like this one is so much higher than this one, but actually it's not like 10 times higher. What else?
There's also really no reason to not just have 5 bars individually labeled and for like 6 individually labeled bars, as opposed to having like this mural over here.
So how would you do that then?
Like, I mean, I guess if you're doing like clustered bar graphs and you'd have this, and then you'd have another year or another observation, which would have all of these 6 groups, then it would make sense. But normally, if you just have 6 bars and you don't plan on having like more grouped ones, you could just, instead of having this whole legend business and these different colors and patterns, you could just have them labeled.
You can just have the label like right next to the bars, right?
Yeah, at the bottom. Yeah.
Right, because now you have to look at this legend and these colors and then go back to the figure. And that is very inefficient because you have to check if I want to know what's the wage if people finish 3 years, then I have to look for this yellow bar and then look at the number. However, if you put this label right here, right next to the bars, then it would be easier to see that. However, now you have so many bars, right? And if you put all of these labels on this x-axis, then you may not have enough space for that. So what we could do is to also flip this figure horizontally. And then we're doing several changes here, right? So first of all, the axis now starts from 0. So then if you look at the lowest group and the highest group, it's not so dramatically different. Although you can still see that it's maybe 2 or 3 times higher, but which is the accurate number. And also we are flipping it horizontally, and that allows us to put these labels right next to the bars. And now if I want to see what is the wage for people who finish 3 years, I can just look at right here and it would be much easier. Okay, what else? I think that's it. All right, so this one, it looks at By the way, most of these before figures, I think mostly comes from Excel, and these after figures are from either R or Python, but I think you can do it in both. Okay, so this is a typical Excel figure. You have this change in weekly wages of US born workers by group from 1990 to 2006. And you have this very little legend here. And these bars are the young group, which are people with experience below 20 years. And then you have the old group, which are people with experience above the 20 years. Then you have these 4 education groups: high school graduate, college, and college graduate. And then for each of these education group, you can see young and old workers, what are their respective wage changes. So what can be improved here? And how would you do it differently?
I would
There's only-
just do it two,
Good.
I would just do it 2D instead of 3D because it's kind of
Okay.
unnecessary.
Of course,
I'd probably change the colors as well so they are more different
More
versus
different?
purple versus blue.
yeah.
And in the legend, I'd make that bigger and I'd capitalize experience just so it's more consistent because that looks bad as well.
Okay, those are all great. Anything else?
You could also do it horizontally if you want, just for simplicity.
You could also do it horizontal and put the labels right next to it. Yeah. Okay. And usually when instead of just putting different colors, you may also want to use different shades in case people are colorblind, or if people are printing it out in like black and white. Okay. Anything else?
The legend might want to be below or above the graph, not in the graph, and you might want to make it bigger.
Okay. But the best thing you could do is to get rid of the legend and just put the labels in the graph. Okay. So you can put a young here and old there, for example. And I guess also these grids are also kind of unnecessary, or you can definitely make it lighter color. Okay, I think that's pretty much it.
Yeah, there's also no y-axis label.
There's also no y-axis label. Great, yeah. There are the changes, but not pretty clear. So first you should drop the 3D and also put the legend back into the graph, and also allow more effective comparison. Let's see what the after figure looks like. So now you still have these 4 groups, and it's in different colors. And I'm only labeling in the first group that this blue bar right here is the young with less than 20 years of experience. And then the other orange bar is the old with more than 20 years of experience. And then I probably only need to do that once, right? Because for the other parts, it would be clear which color is which. So that's one thing you could do. Or you could also have a legend somewhere here. Okay. Next figure. So this one looks pretty complicated. So you have these countries, and then for each country, you have the percentage of people who are employed who are senior managers by sex. And these orange bars are women, and blue dots are men. Well, what would you do differently?
You might stack the bar chart instead of having these diamonds above it. It's not clear that they're even part of the same axis.
So you're saying you can have two bars for each country.
You can do two, or you can stack them on top of each other.
Okay.
Please do not stack them on top of each other. I will come after you if you stack them on top of each other. Two bars is the best option.
You can also flip it horizontally so it's easier to see this country names. What else? You could also get rid of the grids. I guess it's not super helpful here.
I think it would be good to, I don't know, change the title or at least put some helpful label on the y-axis, because it took me like half a minute to figure out what they're even plotting here.
Okay. All right. I think those are all very good ideas. Well, this is one version of improvement. You first flip it horizontally so you could see the country names more clearly. And actually, in this case, in every country, women has lower share of managers than men. So what you could do is to just have these two dots and connect them. And then what's good about this graph is that it also tells you, so looking at how long this lines are or how far these dots are from each other. It's also the gap between men and women, right? And that has a very intuitive meaning. And then you could see which country have bigger gaps and which country have smaller gaps. So for example, Turkey here would have a huge gap, and then US is about here, and then Mexico has a small gap, but that's actually because it's low for both men and women. Okay. Well, I guess we'll do two more, and then you would be pretty good at this. So this figure plots the trends of these four groups. Okay, I think these are different diseases, and the time series of each group.
There's no labels or title.
There's no title, right? What else?
The years could be on the tick marks. Like these things are kind of, they're plotting like bar graphs relative to the years.
What do you mean bar graphs?
I mean, the dates are usually aligned like in line with the grid lines, right? Grid lines and tick marks.
Oh, I see your point. So you're saying the dates should be not between these grids.
Yeah, and
okay,
the dots should also be lined up with the, I mean, they're lined up with the dates right now, but like,
okay, so it should be, it put the marks here and here and here.
Yeah.
And what's the message of this graph? I guess it's to show different trends of different diseases, right? So for some, like the purple line, muscular skeletal, it's on an upward trend, and then the green line, circulatory, it's on the downward trend. Mental is also on the upward trend. But if you want to do that comparison, it's a little bit hard to see here because you have these four lines that are on top of each other. So what you could do is to, instead of putting these four lines together, you could put them, have four sub figures And in each subfigure, you can still have the 4 lines, but only highlight one of them. And that allows you to see for each disease what the trend of that disease is. Okay, it also has a title, definitely. So these are the disability insurance worker by cause of disability. So more people are getting disability insurance because of mental disease, and less people because of the circulatory, for example. Okay, and this serves two purposes, right? First, if you want to know the trend for a particular group, you can just look at that subfigure and that would be pretty clear. And also, if you want to do comparison, you can still do comparison. In each figure, you still keep those 4 lines. So if you want to compare the trend with the trend of others, you can still do that. Okay, I think 2 more. This is the second last one. You have these different groups and it's a pie chart. What's great about pie chart is that it tells you that all of these fractions adds up to 1. Okay, but that's the only thing that pie chart is doing great. However, if you want to compare these different groups, pie chart is not super effective because the size of these different groups would be the size of the pie slices. However, it's very hard to see, it's very hard to compare the different pie slices, like how bigger this one is relative to this one. Okay, so you could do a bar chart if you want to do a comparison. So what we could do is this one, we have a bar chart of each group, but however, we also keep the message that all of these numbers add up to 100%, which is the message from the pie chart. But of course, if your only point is that they add up to 100%, then this would probably be fine. Or you could, again, separate this into 6 subfigures. And in each figure, you only emphasize the pie, the slice of pie in that figure. And this is also probably better for comparison than just looking at the pie chart and trying to rotate stuff. Okay, last one. So this figure tells you what is the source of aggregate income in 2 years. The first year is 1962, second year is 2007. And in 1962, for example, 20% of the income from earnings, 30% from Social Security, 15% from asset income, etc. And then in 2007, the fractions of each of these sources change a little bit. And then the message of this figure, by having these 2 pie charts, of course, first, all of these different groups, they add up to 100%. And second, by having these 2 years side by side, it also wants to do some comparison, right, of the fractions in these different years. So do you think there's a better way to do this graph?
You could show us a bar chart.
So you could do a bar chart of the 2 years. For each category, you can have what is the bar for this year, what is the bar for the other year. Great. Any other ideas?
You could include like the dollar amount, either of the total or of each individual slice, maybe for the larger ones, just so you see like how large the aggregate does increase by.
Okay. Yeah. You could always add additional information to the graph and make it more informative. Any other ideas to redo this graph except the bar chart?
You could do a scatter plot.
You could do a scatter plot. How?
2007 on the x-axis, 1962 on the y-axis.
And what would that scatter plot mean?
Whether it's stayed constant over time.
But that's not easy to see, right? Because if it stays constant, then it would be on the diagonal. So you would have some dots here, some dots here. Usually scatter plot is great for the relationship between X and Y. But in this case, well, we want to see for each group how much higher or how much lower it is relative to the other year, right? But I guess scatter plot is not super intuitive there. Right.
Might be weird for just 2 periods, but you could do some kind of line graph to show like that one is bigger or lesser than the ones from before. You could see them crossing over.
Okay, so it's like the one we saw before, right? You have these 2 dots, and then you can connect those dots. Okay, so let's see some options. The first one is what you have suggested, a bar chart for these 2 years. And then what's great about this chart relative to the original one is that it allows you to do a very easy comparison. If your goal is to compare how much each group have changed, and which groups have which categories have increased and which categories have decreased. For example, Social Security increased, and asset income decreased. And then you can see it increased by like 8% or decreased by 4%. However, the one message that is lost here is that all of these are fractions and they actually add up to 1. Okay, so if you want to also show that, you could, instead of 2 pies, you could have 2 bars. And then for each bar, you can split it into different areas with different, for different categories. So this would also be a substitute then for the pie charts. It remains the message that all of these fractions adds up to 100%, right? But also it's great for comparison too, because for example, you can see that Social Security increased from 30 to 38%, and then earnings sort of keeps the same, and asset income decreased, etc. Okay, it's not as great for comparison as the bar chart, because, for example, this would be hard to see how much or how it has increased or decreased. However, it's better for comparison than the original pie chart, because here, if you want to do comparison, you would be comparing this pie slice with this pie slice, which is pretty hard because you first have to rotate and then you have to look at these 2 angles, which is bigger and how much bigger. And finally, you could do a slope chart. So you have these 2 dots in 2 years, and then you're using that slope to denote whether they increased or decreased. Okay, so if it's upward sloping, then it increased. If it's downward sloping, it decreased. Again, this is great for comparison, so you can immediately see, and here actually it has different colors for the groups that increased and decreased. So you can immediately see which groups, which categories have increased and which categories have decreased. However, it doesn't tell you that all of these fractions adds up to 1. So if you want to emphasize that message, here, this would be your choice. However, if your main goal is comparison, you could do either this or this. Okay, so that's all of the examples. So all of these examples are illustrating this principles that we discussed at the beginning, right? So first you would want to show the data directly and in a non-misleading way. And second, you should reduce the clutter that is unnecessary. And finally, you should integrate the figure and the labels. And what kind of data visualization can we do if we get some data? So there are several types. The first is we can look at the distribution of some variable. And that would be usually for a single variable. And we can see whether it's normally distributed and whether there are some outliers, etc. So you could do a histogram or the kernel density that we have talked about, which is basically a continuous smoothed version of histogram. And the second kind of data visualization is comparison. So most of these figures that we discussed before are comparison, right? So here, you could look at different groups and whether one group has a higher value for some variable than other groups, etc. And the third type is composition. You can break down into groups and see what is the fraction of each group. And finally, you could use data visualization to show is the relationship between several variables. So let's look at each of them. For distribution, a histogram would be great, but remember the histograms that you would finally get are sensitive to the number of bins, right? If you have fewer bins, if you have too few bins, that's probably not very informative because then there's only 2 huge groups. If you have too many bins, then that's probably also not super informative because then it's driven by all of the noises in the data. So then you should choose something in between that helps you to see what is the distribution of that variable. And this is similar to how we choose the bandwidth for the kernel density, right? If your kernel density is too narrow, then it's a lot of volatility and a lot of noise. If it's too wide, then it's basically flat. So you would want to choose the optimal bandwidth to have a most precise characterization of the actual density. And you could also use a scatter plot that shows the distribution of 2 variables, okay? But by doing that, we are also allows us to see what is the relationship between those variables. Okay, so if you look at this graph, it's a scatter plot, and then you have the faded line. Okay, this would be pretty easy to do in Python, right? You can just use matplotlib and then do a scatter plot between 2 variables. And then if you want to add a regression line, you could either estimate a regression line and add that to the graph, or you can just use the Seaborn, which allows you to add a regression line automatically. So what this figure shows you is x-axis is the share of people who wear masks, y-axis is the share of reporting COVID cases in the community. And these little dots are the different states. So you have DC right here, Maryland right here. So all of these are states with very high percentage of people who wear masks, and also pretty low relatively share of COVID cases. And then when you plot all of this on the scatter plot, it's pretty easy to see that there's a negative relationship, right? You can do a line, but even without a line, it would be pretty easy to see. And the other thing it does here is to also use these two different colors to show this two different set of states. So you have the Democratic states in blue and Republican states in red. So then it would also pretty striking that the blue states are on this down right part of the graph, which has very high percentage of masks and very low share of cases. Okay. Composition would be a pie chart. But as we mentioned, right, if you want to emphasize how these different groups compare, and for example, how much group A is lower or higher than group B, then you have to do a bar chart. And that's for comparison, you would always want a bar chart because that allows you to see, as we show at the beginning, right, the length of the bars is easiest to see how these different magnitudes compare. And it's much, much better than the slice of pies. And you could also use a bar chart to compare the different percentiles. Okay, so here you have these different majors, and then what is the expected earnings for the college graduates in that major. And instead of just plotting the mean, we are doing the 10th percentile, 25th percentile, median, 75th percentile, 90th percentile. So by doing this, we not only see if the earnings is higher or lower, so it ranked all of the majors from lowest to highest, but also it allows you to see the volatility of earnings. So some majors probably have a very low volatility, but some may have a much higher volatility. Okay. And the final thing is, what if you have a lot of dimensions in the data and you want to show more than 2 dimensions? Because all of the figures we talk about, it's all either 1 dimension, like the histogram or kernel density, or 2 dimension, like the bar chart or scatter plot, right? So if you have more than 2 dimensions, one thing you might think about is the 3-dimensional graph, but that's always a bad idea because as you can see, if you do a scatter plot in a 3-dimensional space, for example, and it's very hard to see what the pattern is in the data. Okay, so what you could do instead is to add that 3rd dimension using colors. So we have actually seen this in the 2 slides before, right? In this figure, there's actually 3 dimensions. One is the x-axis, people who wear masks. One is the y-axis, the share of COVID cases. And then the 3rd dimension is whether it's Democratic or a Republican state. And this 3rd dimension is represented by different colors. And that's because this 3rd dimension is actually a categorical variable. There's only 2 categories. So then we can use 2 colors to denote these 2 categories. In this example as well, we have, so this would be a figure that you can plot using Python. So you have the X variable, Y variable, but also a third dimension, which is a different color. Okay, so this figure actually is also plotted by Seaborn, I believe. In Python, the most common packages for plotting would be matplotlib and Seaborn. And that pretty much would cover all of your needs. If you want to know how to use that, so we actually covered some of them throughout this course, but if you want to know more, then you should take this course on DataCamp that walks you through how to use these different functions in Matplotlib, for example, to plot these different types of figures. Oh, and another thing is, if you have a third dimension, if that's a categorical variable, you can use different colors. If 2 categories, 2 colors, 3 categories, 3 colors. However, if it's a continuous variable, what you could do is a bubble chart where you can use the size of the bubbles to represent the third dimension. So in this figure, it's actually a very rich figure, right? Because it has 4 dimensions. The first dimension, so all of these are different products. The first dimension is the consumer rating of each product. Second dimension is the revenue of each product. A third dimension is the product type. So there are 4 categories. And the fourth dimension is the product cost. So if you look at this product, for example, it has pretty low rating and relatively lower revenue, but it has huge cost because the size of the bubble is pretty big. And it's type 1 product. Okay. And you can do that for every, you can look at each of these bubbles and see what they are. And in general, it can probably also allow you to see some patterns. Right, so for example, product 4 usually have pretty low cost, and 1 probably have higher cost, etc. Okay, so that's also another option if you have a third dimension, which is a continuous variable. Okay, and as I said, if you want to know how to program using these different libraries in Python, like Matplotlib and Seaborn, then you should take the course on DataCamp that walks you through that. And there are actually a lot of resources on data visualization as well on DataCamp and other places. And I also added a example. So I'm not going to cover it in class, but I will just leave for your own reading. So there's a very small example that plots a graph in Python in this lecture folder. Let me show you where it is. Okay, so it's this one, visualization notebook. So basically all of the things in Python, you would have different layers of the graph. So this one is actually using ggplot, which is kind of a similar language as R, but it works similarly as Matplotlib. So you can, for example, you can first do a line graph, and then you can add on top of that to have a scatter plot, and then you can add on top of that all of these other things. So all of these packages work this way, that you can add different kinds of graphs to the same figure. And then you can add the labels and titles. Okay, so now let me talk a little bit about the exam and some logistics. So as we agreed at the beginning, for those of you who may come late, the exam will be from noon of Thursday in 2 weeks, which is March 11th, to 24 hours later, which is noon of March 12th. And it should not take you more than 2 hours in total. And in our lecture folder, I have uploaded 2 things. One is the final of last year. It will be a little bit different from this year. But last year, it's all conceptual questions and there's no coding because it was a different format, and it's not, you don't have all the resources available when you're doing the exam. But this year, there will be 2 parts. One part, it will be conceptual questions, just like last year. So this would be a pretty good representation of what is the kind of questions you're going to see. And then the other thing, and then the second part of the exam will be a coding exercise, which is just like the exercises that we do in class. So all of those places in the Python notebooks that's marked exercise would be good for you to exercise if you want any. And the other document that I've uploaded is a study guide that's basically an outline of all the topics that we've covered, and everything that will be in the exam should be one of the things on this outline. And that gives you a map to study for the various topics that we've covered. And then regarding the logistics, we still have 2 more lectures next week. And on Tuesday, because I'm actually expecting a baby this weekend, so I won't be able to do a live session. However, I will upload a video that I will talk through this study guide and just help you to review some of the concepts that we've seen. So just like I would normally do in the review session. And then the TA, Kai, has also very generously offered to teach the session next Tuesday. So you should still attend the session if you can. And he will talk about the final of last year, because I'm not going to post solutions because I don't have an actual solutions, but Kai will talk through the answers for all of these questions. And you can also ask him questions about this practice exam or about anything in this course. And he will use that also as a Q&A session for this course. And then I will have an additional office hour later next week. And then Thursday would be normal that we're going to have the final project presentations. And if you haven't signed up for a slot yet, you should do that. And the report and code for the project is due on Sunday, which is a few days after the presentation. So that was intentional because you can use the presentations to get some feedback from me and from your classmates, and then you can revise your code if need be. Okay. Any questions?
Professor, I wonder what is the due date for DataCamp courses?
I would say end of next week, because that would be the beginning of the exam week.
Okay, thank
like
you.
March 7th.
So how many questions are we expecting for the coding part for our final exam?
Oh, there will be just one data set. And then I'm not sure how many questions, but like the coding part should not take more than an hour. So each part would be an hour. So the conceptual part will be half of what last year's exam is. Then the coding part should be an hour. I guess I would say, yeah, maybe 5 or 6 parts.
Professor, for the coding, what's the best way to prepare? Is it like a specific problem set that we should go over, both the problem set, any?
Yeah, definitely the problem set and the all of the in-class exercises. And in those Python notebooks, you can sometimes see that like there's a note that says exercise, and then maybe you can just redo those exercises. And that would be a good enough practice, I think.
And is it going to be like short coding, or is it going to be like multiple coding in one coding, if that makes sense? Like complex coding.
It will be like, it's kind of like you have to fill in the blanks of some.
Oh, okay. Got it.
Professor, so that like if we filled like for the first answer for the coding, we filled it wrong. So will that affect the other coding?
Won't affect your score, because all the
Oh, as
like
long
all
as
of
the
it will
coding.
be, yeah, all of it will be graded based on your code, not your result.
Yeah, okay. So you're saying that Tuesday we have like Kai will teach us, right?
Yes, Kai will go through the last year's final and do a Q&A session.
Okay.
And I will do an office hour or Q&A session later this week, next week.
So you basically
Oh, and
you will
next Tuesday's
provide-
office hour will be canceled, and we'll move to later in next week. Sorry, Ray?
Yeah, sorry, Alex. So basically you will provide us like a notebook, right? Like the homework format, so that we can open it and do the coding part.
Yes.
Good. It's very, very challenging to me. So I want to make sure that, thank you.
Yeah. And well, if you don't have any questions, you can feel free to leave the meeting, but I will stay here until about 8:50. So if you have any questions about the homework, you can ask them now. And I'm sorry about the PyEarth package. So that was a new issue that's happening just these last few days, because it was working when we were teaching that part last week, right? 2 weeks ago. It was very weird. But let me know if any of you have found any solutions, and I will keep seeing if there's any way to get around that in Google Colab.
Professor, just a quick question.
So I did it
where can we-
using,
Okay, so one at a time.
I'm
Ray,
just
you go
asking
first.
where can we find the slides like in your lecture today?
In my lecture today, I'm gonna upload it now.
Oh, thank you.
so I used the Mars package, and I had it working, but now it isn't. Do I need to switch it to the spline, or can I just leave it?
Oh, if it was working, then you can just keep it.
It was, but now it's not.
But I got the same I got the result, even though, it does not work right now, but I got the result. So I don't think I should change the entire coding, right, Jack? Like my question is the same as Jack's question.
Well, if you already have done that part, then you don't have to redo it.
Yeah.
If that's what you're asking. Yeah, and if I was not clear, Jack, if you have done that part and now you rerun it and erase the result, then it's okay. You don't have to redo it.
Okay, thanks.
Professor, I had a question for the coding and so if it's a coding question that perhaps perhaps you don't know the right code, or if it's not like you're not able to work through, is it possible just to talk about of what you would do and what packages you would think you would use? Or like just the concept behind it? Would you get partial credit for that?
Yeah, but all of the things that I will ask you to do is the things that we've already done in class. So there won't be any new packages, if that's what you mean.
Okay.
Yeah, like for
Because I was thinking like if you try the code and the code doesn't work for whatever reason, I was
Uh-huh.
thinking
then you will
if
get
there are
partial
ways
credit
to get.
if you get some error, but the code looks about right.
Okay, got it.
So, quick question for that question 5 Mars problem, the PyEarth problem. So I gotta do Conda and using a link like to install the package, and then like running it through Conda Python. So it's got the result. However, there's like warning for the result. I wonder if that's gonna be an issue of affecting the numbers.
Can I see your result? If you had some results, right? Can I
Yeah.
see it?
Yeah, sure. Can I share screen?
Yeah, you can share now.
Sure. Yeah, one sec. Okay. Yeah, can you see it?
Yes, I can see it. But
Okay.
this is question 2.
Yeah. Going back. Okay. Yeah, so these are the warnings kind of.
Okay, but did you plot the? Okay, let me see what this earning said. Yeah, it's all like future warning. I don't think it matters.
Okay.
Yeah, but can you also try like plotting the prediction to see if it looks like what it should be?
So
So you can just plot the like predict Mars against test X, I guess.
So just like this, Mars?
Well, I think it's well, I also don't remember the exact.
Can I do this too?
Yeah, I think it's just like PLT. Like PLT scatter and X variable goes first and then Y variable goes next. No, it should be test X in your case. Test underscore X and then predict Mars.
Should there be parentheses?
No, I think this is good.
Oh,
Comma
like,
and then. Oh no, you should have the.
Oh, have the comma.
In the parentheses, yeah.
And predict Mars, like this.
Yeah, I think something like that. If you have already in. Okay, yeah.
Okay.
I think this looks about right.
Oh, good. Great. So the warning is okay. Okay. Awesome. Thank you.
How did you, oh, you're using Anaconda.
Yeah, so I download and kind of then used this link
Uh-huh.
install and see to install the iPackage, and then I mean the PyEarth package directly,
Okay.
and then do the let's see what's that terminal.
Okay. Yeah, that's what Kai told me, that it worked in Anaconda but not in Google Colab. So
Yeah, you kind of have to download it.
So, quick question about data preparation. So,
sorry, I can't hear you very clearly. Your volume is very low.
can you hear me now?